All right, greetings, scholars. Beautiful mind here, and we are continuing chapter 4 on trigonometric functions with section 4.2, the unit circle. A few objectives here. 1, review properties of the unit circle. 2, define trigonometric functions of real numbers. 3, find exact trigonometric function values using a terminal point on the unit circle. 4, define trigonometric functions of any angles. 5, find trigonometric function values of an angle in standard position. And then 6, approximate trigonometric functions using a calculator. Okay. So let's take a look at the unit circle. The unit circle is a circle of radius 1 with its center at the origin. In the xy plane is a set of points x, y that satisfy the equation x squared plus y squared equal to 1. So the circumference of the unit circle is 2 pi. This means that the arc length for one revolution around the unit circle is 2 pi units. If the point P equal to x, y is a point on the unit circle, then the following symmetric images of P are also on the unit circle. The point Q, which is going to be x, negative y, if we reflect about the x-axis. So if we start with the point P, x, y, if we reflect about the x-axis, we'll generate Q, which is x, the order pair x, negative y. Then we'll generate the point R, which is negative x, y, if we reflect about the y-axis. So if we start with the point P, x, y, we reflect about the y-axis. So that means our y value stays the same, but our x value changes sign. So that's why we get negative x, y. And then we generate the point S, which is the order pair negative x, negative y, if we reflect about the origin. When we reflect about the origin, we change the sign of not only x, but we also change the sign of y, and we get this. Okay. So, like, one thing you'll kind of start to notice is that, like if you get a point in quadrant 1, then it corresponds. You reflect over the y-axis, we get a point in quadrant 2. We reflect over the x-axis, we get a point in quadrant 3. And if we reflect about the origin, we get that point in quadrant 3. And Q, the other one was in quadrant 4. I think I said that, but anyway, let's keep moving. So find out points on the unit circle whose y-coordinate is 3/5. Okay. Let me think about this. Okay. So we're going to if we're working with the unit circle, let's start here where we have this x squared plus y squared equal to 1, right? If our y-coordinate is 3/5, so let's just plug in 3/5. So that means we're going to have x squared plus this 3/5 squared equals 1. So then let's solve for x from here. Okay? So then 3/5, what is that, 9/25? Okay? Subtract the 9/25 from both sides. So 25 minus 9, 25, 15, 16. So that becomes 16/25. And then when we go to take the square root on both sides, x equals plus or minus 4/5. Okay? So find all points on the unit circle whose y-coordinate is the positive 3/5. So it looks like I'm getting 2. So namely, the ordered pair negative 4/5, 3/5. And then I'm also getting a positive 4/5, 3/5, right? Because these x and y values, when we plug it into that unit circle equation there, they both equal 1, okay? I know this is going to act up a little bit. Oh, I didn't do it. Okay, fine. Oh. Let's see, how do we do? So we need to find the x-coordinate of all points of any of this form that satisfy this equation. So let y be 3/5, and looks like they got the same results that we got. Okay, that's fine. So let t be any real number, and let the point P be the order pair x, y be the point on the unit circle associated with t. Then we have the following. Let me see. So now, as a disclaimer, right? So I'll kind of say this. So, in the previous section we looked at like central angles, and then we have an arc length and things of that nature. So in this context, the t is like the arc length. All right, that seems to be a pretty safe, fairly safe, So we can kind of go with that. So t is any real number, and let the point P is identified by the order pair x, y be the point on the unit circle associated with t. Then the sine of t, right? So you can almost do like, if the point is the order pair x, y, x is going to be the cosine of t, and y is going to be the sine of t. So these order pairs are like cosine t, sine t. And then once you have cosine and sine, tan is sine over cosine. Let me see, SOHCAHTOA. I think we can introduce SOHCAHTOA here, right? I mean, maybe not. We don't really need that just yet. But, sine, so sine of t is y, cosine of t is x. Tan is sine over cosine. So that gives us the y over x. The reciprocal of sine is cosecant, so it's just going to be 1 over y as long as y is not 0. The reciprocal of cosine is going to be what? Secant, which is going to be 1 over x. And the reciprocal of tan is going to be cotan, right? So with a lot of these, like once you find sine and cosine properly, then the rest of it's just, it's a little bit repetitive at that point. You'll see it. Let's kind of keep going. So cosine and sine. The terminal point P of t equal to x, y on the unit circle associated with the real number t has the coordinates cosine, sine, because x equals the cosine of t and y equals the sine of t. All right, so we have a point P. Then you can see here where t is the arc length associated with that point. All right. And then again, x is the cosine of t, y is the sine of t. Okay. And then once we have sine and cosine, we can generate the remaining trig functions. Okay. So find the values of any of the 6 trig functions of each value of t. So when t is 0, right? So the order pair when t is 0 is going to be the order pair 1, 0. We'll find the 6 trig functions associated with that, and so on and so on. We'll take a look at each of these. So when t is 0, right? So let me see. So then p of 0 is going to corresponds to the order pair 1, 0. That's going to be our cosine of 0 and our sine of 0. Okay. So if we want the 6 trig functions, right? All right, I'm gonna see one thing real quick. Okay, that's fine. So for instance, if we did the sine of 0, that's what going to be 0, right? Match up the corresponding spaces. The cosine of 0 in this instance is going to be a 1. Now that we have sine and cosine, tan is going to be what? Sine over cosine. So then the tan of 0, 0 over 1, which is going to be 0. Okay. Disclaimer, let me do this off to the side. So if we have 0 over some number k, this is okay. All right, so that's going to be equal to 0. So when we did sine over cosine, we did 0 over 1, that's okay, we got 0. If we do some number over 0, you want to knock that out. That's a KO. You want to knock that out. So that's going to be undefined. Okay, so I just want to kind of make that distinction. So then the reciprocal of sine is going to be cosecant. So cosecant of 0 does not exist or is undefined. So that's going to be undefined because you can't take the reciprocal of 0. I'm going to just abbreviate it. The reciprocal of cosine is what? Secant of 0. So reciprocal of 1 is going to be a 1. And the reciprocal of tan is cotan. Again, that one's also going to be undefined. I knew it was going to do that. That's okay. Okay. Oh, shoot. How can I get you? You are like right in the middle of that. Okay. All right, let's see how do we do. Oh. Okay, yeah, let's do the others and well, I kind of want to check that first one. Sine of 0 is 0, cosine of 0 is a 1, tan of 0 is 0, and then undefined, 1, and undefined. Okay, so that's fine. So then for b, now 3 pi over 2. So if t is 3 pi over 2, now here what I like to do, going like 90, either 90 degrees corresponds to pi over 2, right? So sometimes I'll count it like this. You know, I identify this as what? 0 pi over 2. This is 1 pi over 2. This is 2 pi over 2. And then down here is going to be 3 pi over 2, right? So if we start in standard position and we count 0, 1, 2, 3 pi over 2 puts us at the point 0, -1, right? Okay. So then p of 3 pi over 2 corresponds to the ordered pair 0, -1, okay? So let's do here 3 pi over 2. That corresponds to the ordered pair 0, -1, right? Keep in mind that these go what? This is the cosine of t. This corresponds to the sine of t, okay? So then from there, we should be able to generate everything. So then the sine of 3 pi over 2 from this looks like it's going to be -1. The cosine of 3 pi over 2 is going to be 0. And then the tan of 3 pi over 2, sine over cosine, looks like it's undefined. Okay. So then the reciprocal of sine is what? Cosecant of 3 pi over 2. Looks like that's so if we flip that, we're going to get a -1. The reciprocal of cosine is secant of 3 pi over 2. That one's going to be undefined. And then the reciprocal of tan is cotan of 3 pi over 2. Should be 0. Okay. So let's see, how do we do? Oh, well, yeah, I kind of want to go ahead and check this. Uh, okay. And I think we're good there as well. Those look good. Okay. And then, so now t is going to be a negative 3 pi, right? Let's see. So negative means we need to go clockwise, and we can just count by pi. So pi is like 180 degrees. So let me see. Here's 1 pi. Here's 2 pi. So then 3 pi should put us here, right? Okay. So then p of a negative 3 pi should correspond to the ordered pair negative 1 comma 0. So p of a negative 3 pi should correspond to the ordered pair negative 1 comma 0, right? Again, this corresponds to, this is our cosine of t, this is our sine of t, and then we can kind of use that to kind of move forward, right? So then the sine of a negative 3 pi should be, what, 0? The cosine of negative 3 pi is going to be negative 1. So that means tan of negative 3 pi is what? Sine over cosine. So 0 over negative 1 is going to be 0. The reciprocal of sine is cosecant, negative 3 pi. That one's going to be undefined. The reciprocal of cosine is secant of negative 3 pi. That one should be negative 1. And the reciprocal of tan is cotan of a negative 3 pi. And that one's going to be undefined as well. Okay. All right, so we got 0, negative 1, 0, undefined, negative 1, undefined. Let's see, how do we do? Okay, I think we're good. Okay, so with these examples, the main thing was that, identifying that the x coordinate corresponds to cosine of t, the y coordinate corresponds to sine of t. Once you have sine and cosine, then you can generate the remaining trig functions. Tan is sine over cosine, and then the other three are the reciprocals of the ones of our previous three trig functions. So given our t, we have the corresponding terminal point. Again, t is like the arc length of that central angle and standard position. Now, when I was learning these, I would use like the degree measure, and like that's just how I would visualize it. Let me think. Terminal points, sine. This is fine. I want to kind of jump ahead just a little bit to show you something. It's not here though, but that's fine. We'll use the table. So here, use the table on the previous slide in symmetry. Hey Google, enable nighttime work mode. Use the table on the previous slide in symmetry to find sine of t, cosine of t, and tan of t for a negative pi over 3.
I can't enable a nighttime work mode as I don't see a device that supports this feature. I also can't help with mathematical calculations.
Okay, maybe let me try one more time. Hey Google, enable nighttime work mode. There we go. I was like, I know she can do this. All right. So if we want a negative pi over 3, right? We can use symmetry. So for instance, we have pi over 3. If we look at the chart, P of pi over 3, that's going to put us in quadrant 1. That's if we had a positive angle. But since we have a negative angle, we have a negative pi over 3. That's going to move us down into quadrant 4. Right, so we're basically reflecting over the x-axis, which means our x values stay the same, but the y values go from positive to negative. So pi over 3 corresponds to the ordered pair a half comma root 3 over 2. Okay. So then from the table, we have what? P of pi over 3 corresponds to what? 1/2 comma root 3 over 2. So then if we want, we're just going to say, we're going to call ours a Q, and we want it to be a negative pi over 3. So instead of being in the first quadrant, we want to be in quadrant 4, which means that what? X is positive and Y is negative. So that's going to correspond to 1/2 comma a negative root 3 over 2. Okay. I am going to move this. Uh-oh. You're going to act up? You surely did. Let me see if I can get this. Ugh. Undo. That is really throwing a monkey wrench in my stuff. Okay, I think it's just the one. That's fine. I'll get rid of that. Undo. Let's duplicate. Okay, I'll move you here. Come on, delete that. And I guess I'll just try erasing this, and that should hopefully work. Okay. Okay. So now again, we want to find the trig functions associated with this point Q, with this Q of negative pi over 3. This corresponds to cosine of t. This corresponds to sine of t. Okay. So now, so what we're saying is that what our sine of negative pi over 3 looks like it's going to be a negative root 3 over 2. Our cosine of a negative pi over 3 looks like it's going to be what, a half. So then once we have our sine and cosine, tan of a negative pi over 3, we do sine over cosine. So it looks like it's just going to be a negative root 3. Okay. The reciprocal of sine is cosecant. So negative 2 over root 3. We usually rationalize. We typically don't leave radicals in the denominator. So in order, are you going to act up? You probably are. Okay, good. So to rationalize, we multiply by 1 in the form of root 3 over root 3. And we'll get a negative 2 root 3 over 3. Okay. The reciprocal of cosine is secant. So that's just going to be a 2. And the reciprocal of tan is going to be what? Cotan. It's going to be a negative 1 over root 3. Again, we rationalize. We get a negative root 3 over 3. Okay, let's see how do we do. So again, we got like this result, that result, that result. We got this result, and that result. Okay, let's see how do we do. Where'd it go? All right, am I missing a slide? I think I am missing a slide. Let me see, what's on this one? Let me see. Let me see if I can find this missing slide that I think we have. So if I go here, let me see. Okay, is that it? That looks, no, that's not it. Oh, this is gonna be in temperamental. Oh my goodness, this is driving me nuts. It keeps jumping. All right, that's not working. So, was that it? And we got that. I think it's just missing a slide. Yeah, because these are unedited. Okay. Okay. Use the table on the previous slide and symmetry to find sine. Oh, they just wanted sine, cosine, and tan, so we didn't need the cosecants. That's fine. All right, so we didn't need the reciprocal functions. Negative root 3 over 2, 1/2. Let me see. So sine, cosine, and tan. I think we're good. So we did have some extras. Okay. All right, not too bad. So trigonometric functions of an angle. If theta is an angle with radian measure t, then the sine of theta equals the sine of t, cosine of theta equals cosine of t, so on and so on. If theta is given in degrees, convert theta to radians before using these equations. So theta is an angle with a radian measure t. Again, if the angle is given into degrees, we need to convert from degrees to radians. Then we can do this. Okay. So find the trigonometric function values of 90 degrees. Okay, so let's start by converting 90 degrees to radian measure. I'm pretty sure. I'm going to just try to work with it. Okay, so if we have 90 degrees, I'm going to put it over 1. I'm going to say times what? 180 degrees corresponds to pi radians. All right. The units of degrees cancel. Those trailing zeros cancel. So then it looks like we're left with pi over 2 radians, or just pi over 2. Okay. So now we've converted from degrees to radians. Now, when we consider p of pi over 2, that's like our 90. So that means that's going to be associated with the ordered pair 0, 1, right? Because we're up at the top. So 0, 1. Keep in mind, this is what our cosine, this corresponds to our cosine of t, this corresponds to our sine of t. Okay. Find the trig function values. So then the sine of what, 90 degrees should be a 1. The cosine of 90 degrees should be 0. The tan, say sine, cosine, yep. The tan of 90 degrees, sine over cosine, that's going to be undefined in this case. The cosecant of 90 degrees is a 1. The secant of 90 degrees is going to be undefined. And the cotan of 90 degrees should be 0. Okay. So 1, 0, undefined, 1, undefined, 0. 1, 0, undefined. Yeah, we got it. Okay. So we have our t again. T is like our central angle. Okay. So honestly, when I first learned these, I learned it using the graphs. The one that made the most sense to me was using the graphs of sine and cosine. We're not there yet, so I'm gonna try to match the way the book does it as best I can. So again, when our real number t is given to us in radians, then the radian measure matches, and then we can convert from radians to degrees. Okay, so now all of this really we get it from the unit circle. So let me see. Okay, I'm gonna use it over here, right? This guy. So this is the unit circle. Pi over 6. If we did no. Okay. 30, 45, 60. So when looking at the unit circle, let's just focus on quadrant 1, right? We got our 0 degrees, 30 degrees, 45, 60, 90. So then if we have those degrees, we can convert them to radians, right? So to like 90 degrees in radians is pi over 2. 60 degrees, we would say what? 60 degrees times pi over 180 to give us pi over 3. So we can convert from degrees to the radians. So then if we were going to generate this unit circle on our own, on the axes, at 0 degrees, we have the ordered pair 1, 0. At 90 degrees, we have the ordered pair 0, 1. And then for these 3 points, for the 60, 45, and 30, if I were going to generate this on my own, notice that all the denominators are 2. And then if we can count 1, 2, 3, we can generate those guys, right? So look right here. We go what? 1, 2, 3. 1, 2, 3. Take the square root of all the numerators, and then that's where we get those. So then once we have quadrant 1, we can use symmetry to generate everything else, right? So then 30, 140, 135, 150, right? So if we take that quadrant 1 and reflect across the y-axis, right, the x values stay the y values stay the same, but the x values go from positive to negative. If we take that quadrant 1 and reflect over the x-axis, the x values stay the same, but the y values change sign. And if we reflect about the origin, both x and y change signs, right? So again, if I were going to generate this unit circle on my own, like if I was in a proctored environment and I wanted to use the unit circle, again, I would do my 0 degrees, I would do my 90 degrees, I have my 60, 45, and 30, convert them all to radians. And then for those 3 points in the middle, all the denominators are 2. And then it counts 1, 2, 3, 1, 2, 3. Take the square root of all the numerators, and that'll generate those points there. Then use symmetry to generate the points in the other quadrants, right? And then go ahead and fill in the rest of the degrees with the corresponding radian measure. Let me see. 12. Does that work? But yeah, once you have degrees, you can just do calculations to find the radian measure. Over 6. I think 12 would work. What is that one? Pi over 12. Anywho, right? So, we can use this as a reference and things of that nature. Let's kind of keep going. So the values of the trig functions of an angle theta. So let P, identified by the order pair x, comma y, be any point on the terminal ray of an angle theta in standard position other than the origin, and let R equal the square root of x squared plus y squared. That's like, x squared plus y squared equals R squared. And if R is positive, then sine of theta equals y over R, cosine of theta equals x over R. And then once you have like sine and cosine, you can pretty much generate everything else. Tan is always going to be what? Sine over cosine. All right, so we'll get y over x. The reciprocal of sine is cosecant. The reciprocal of cosine is secant. And the reciprocal of tan is cotan. Okay, let's see if we can see this in action. So suppose that theta is an angle whose terminal side contains the point -1, 3. Find the exact values of the trig functions. Okay, I went on and left R in there. R equals the square root of x squared plus y squared. So then we get that R is going to be 10, right? Okay. So we just said what? The sine, should be sine of t, sine of theta. So, okay, that's fine. That corresponds to our y, so that was going to be what? Our y over R. So we have this point, P is what? -1, 3. We found that our R was the square root of 10, okay? So sine of theta should correspond to what? Y over R? So it should be 3 over root 10. We rationalize. Okay. So then we get 3 root 10 over 10. Okay. With that sign, then cosine of theta should be what? X over R. So it's going to be a -1 over root 10. We rationalize. Negative root 10 over 10. So I feel pretty good about these. So then now that we have sine and cosine, so then tan of theta is what? Sine over cosine, so that's going to be y over x. Basically a -3 in this case. -3 over -1 to get this. So the reciprocal of sine is what? Cosine? Nope. Reciprocal of sine is cosecant. That's going to be our R. So what? 10 over, it's going to be R over Y. Root 10 over 3. Reciprocal of cosine is secant. It's going to be R over X. Okay. Looks like that one's going to be a negative square root of 10. And then cotan of theta is going to be X over Y. -1 over 3. Okay. So let's see, how do we do? 3 root 10 over 10, negative root 10 over 10, -3, root 10 over 3, negative root 10, and -1/3. Okay. Okay. We got 10 slides. We're almost there. I know it's kind of dragging out, but we're almost there. Use a calculator to find the approximate value of each expression. Round your answer to 2 decimal places. Do I have my calculator handy? Okay. All right. So now if we wanted in our calculator, if we wanted to calculate the sine of 71 degrees, I'm working on the TI-83 plus. So first thing is we need to make sure that our units are in degrees. You can see on that third line right now, we have radians highlighted. We need to switch it over to degrees and then calculate. So I'm going to hit sine of 71. Okay. So for A, we got approximately, it says to 2 decimal places. So that's like 0.95. For B, now in B, we're working with what? Radians. So I need to go back to mode and put it back into radian mode. And then let's do tan of 5 pi over 7. We get approximately negative 1.25. And then for C, that should be in radians. I think that's okay. I'm going to do secant of 1.3. Secant is the reciprocal. Let me think about this one. Is the reciprocal of cosine. So we should be able to do 1 over the cosine of 1.3. Make sure it's in radians. 1 over the cosine of 1.3. $3.74. Okay, let's see how do we do. For A, we got approximately 0.95. For B, a negative 1.25 and 3.74. Okay. Again, for C, make sure it's in radians. Secant is the reciprocal of cosine. Okay. So we have the signs of the trig functions based on the quadrant. You know, in quadrant 1, everything is positive. In quadrant 2, x is negative. In quadrant 3, everything is negative. And when I say everything, I mean x and y. And then in quadrant 4, our y is negative. Okay. So given that tan of theta is this and cosine of theta is this, find the exact values of sine and secant. Okay, so notice that tan is positive and cosine is negative, so that means our sine has to be negative as well. Okay, so I'm tempted to do this. So use this r equals the square root of x squared plus y squared, right? We're given what? Tan of theta is 3 over 2. So is that, let me see, that's our sine of theta over cosine theta. Is that our y over x? Okay. That's our y over x. That's fine. Okay. So it says cosine is negative, so that means our x is negative, which means our y also has to be negative. Okay. And so it looks like it's going to be a negative 3 over a negative 2. Okay. So then if we want to find our r, so based on that, our r should be negative 2 squared plus negative 3 squared. Take the square root. That's a 4 plus 9 is 13. So the square root of 13. Okay. So it looks like we're in quadrant 3. Let me see. It looks like our x. It looks like our x is what? Negative 2. Looks like our y is negative 3, and it looks like our r is the square root of 13. Let's just check things real quick. This gives us what? A positive, a tan of 3 over 2, because if we do y over x, we get a positive 3 over 2. Our cosine is negative, which is going to be x over r. Okay. Okay. So then if we want sine of theta, sine should be what? Y over r. Our y value is a negative 3. Our r is the square root of 13. Negative 3 root 13 over 13. Okay. And then the reciprocal of sine is cosecant. So for secant, secant is a reciprocal of what? Cosine. Okay. So then let's see. Secant theta. If cosine is going to be x over r, so that means secant is going to be r over x. So that's going to be root 13 over our negative 2, or ultimately we get this. Okay. So for sine of theta, we got negative 3 root 13 over 13. And for secant of theta, we got a negative root 13 over 2. Let's see how do we do. Negative 3 root, looks like they got an extra root, so that root's not supposed to be there. It should just be negative 3 root 13. I think they just forgot to remove the extra radical. So I think what we have is fine. And then we got a negative root 13 over 2. Okay, I think we're good there. Okay, we're almost there. So the theta in degrees, so coterminal angles. So this basically alludes to like when we're working with angles that do more than one full revolution. So what we want to do is kind of truncate, like we get the maximum number of full revolutions that get closest to our number as possible. We truncate the full revolutions, and there should be some remainder, and then we just pretty much work with the remainder, right? You know, so it's going to be identical. It's going to behave identically to something without those excessive revolutions. Okay, and we can do it in either degrees or radians. Oh, is that it? That was it. Okay. So we kind of made our way through it. The unit circle. Let me kind of do a quick demo real quick here. A quick demo real quick. That's funny. I mean, the main thing I just kind of want you to see again with the unit circle. And I'm just going to focus on quadrant 1 for right now. So, you got something like this. This corresponds to the ordered pair 1, 0. This corresponds to the ordered pair 0, 1. Now this is our 90 degrees. This is our 0 degrees. And then we got these 3 points here, something like that, and like that. This corresponds to 45 degrees, 30 degrees, 60 degrees. Now, if we want those ordered pairs, all the denominators were 2. Right, so 2, 2, 2, 2, 2, 2, 2. For the numerators, we just count 1, 2, 3, 1, 2, 3. Let me think. I think it went this way. 1, 2, 3, 1, 2, 3. Pi over 6. So we're saying that the cosine of pi over 6 is a half. Let's see. So the cosine of pi over 6, we should get a, maybe I got it backwards. Okay, I think I might have it backwards. Okay. So let's revamp this right here. All right, it goes, instead let's do 3, 2, 1, 3, 2, 1. And we take the square root of all the numerators. Okay. So now, hey, did I do the same thing? I think I just did the same thing. I think I did. I don't think I made the change, right? Because we said the cosine. Okay, let me fix that. Let me back up again. All right. Okay, there it is. It's supposed to go 1, 2, 3. I think that's it. 1, 2, 3. Take the square root of all the numerators. Okay, now. Okay, so now I think we're good, right? And so we can check square root of 3 over 2, the square root of 3 over 2. Okay. So then, once we have quadrant 1, we can use symmetry to generate all the other ordered pairs. All the ordered pairs are pretty much like this. When we're in quadrant 2 on the left-hand side, the y values stay positive, the x values become negative. When we're in quadrant 4 on the right-hand side, the x values stay positive, the y values are negative. And when we're in quadrant 3, both x and y are both negative. Find the corresponding degree measure, and then also go ahead and find the corresponding radian measure. So for instance, in radians, this guy would be what? Pi over 2 radians. This guy is 0 radians. Let me see. 60 degrees. I think that's pi over 3 radians here. All right. 60 divided by 180. I think this one is what? Pi over 6. Is that one pi over 4? 45 divided by 180. Pi over 4, right? Pi over 4 radians. So again, if I were constructing the unit circle in totality, I would do the degree measure all the way around. We finally straighten out that whole 1, 2, 3, 1, 2, 3. Once you can get quadrant 1, then you can use symmetry to generate all the other points in the others. Then you can use it as a reference. Like if you were in like a practice environment, you can just generate this, just practice it a few times and it'll sink in, and I know that the way I have it is intended to use it, I really don't intend for us to be in a practice environment, but that doesn't mean that you won't find yourself in a practice environment. At some point, there's a good chance that you'll find yourself in a practice environment where you'll be responsible for this information. So you still want to prepare as if you're going to be in a practice environment, and you'll learn it better, and you'll be better off. Okay, I think that's it. And so with that, we're going to go ahead and end the session here. And from one beautiful mind to another, have a wonderful day. Take care and peace.